And welcome back to Mr. Gregore's Math. We've done some recalibration and I've remembered that y is up and x is over, and thank you, Simone, for helping me out with that. We're going to determine the shortest distance from a point e, negative 3, 2. I'll go ahead and make a little sketch here. So I'll put my point e, I don't know, somewhere right there. So that looks like it's negative 3, 2. And that's my point e. And then I'll put my point f, 0, 12, appropriately on the y-axis, and my point g, 6, 0, appropriately on the x-axis. So I have a few steps here to find the closest distance from this point to the line connecting these. The first thing is I have to find the equation of the line from f to g. So come on over and we'll find the equation of that line. So the equation of the line from f to g. First, whenever we need the equation of a line, we need its slope. So let's find the slope from f to g using y2 minus y1 over x2 minus x1. So looking at our points, we're going to have y2 being 12 and y1 being 0. And we're going to have x2 being 0 and x1 being 6. So we'll have 12 over negative 6 or negative 2. And that makes sense because our slope looks like it's going down 2 units and over 1. The last thing we'll need is the y-intercept. Well, fortunately, I know the y-intercept because f is the y-intercept. So the equation is y equals negative 2x plus 12. And you know what? I'll just write that there as well too. The next thing I'm going to need is I'm going to need the equation of a perpendicular line. That's the line that connects point E to my original line. So I want to have that being perpendicular, which means the slope of this particular line, I'll erase this part right here so you can see it, the slope of this line is going to be negative reciprocals of this. So we'll reciprocate 1 over 2, and we'll make it negative. Because it was negative, that makes it a positive. So we now have the slope of that particular line. So now we have to find the slope from E to the line FG. I'm going to just call this point here D, so that we know, hey, we're going from E to D. So come on over and we'll find the equation of the line from E to D. So finding the equation from E to D. So we already know the slope. It's 1/2 x, but we don't know B, the y-intercept. So to find that y-intercept, we're going to use any one of the points we know is on the line. That's point E. So it has a y value of negative 2 and an x value of 3, negative 3. So I can go ahead and find B now. Unfortunately, it is a little ugly with fractions. So I'll go ahead and multiply negative 2 equals negative 3 over 2 plus B. And I have to add 3 over 2. So negative 2 plus 3 over 2 is going to be equal to my value for B. Now this is negative 4 over 2, so I'm going to end up with negative 1 over 2 as being my y-intercept. So the equation from E to D, I'll plot it over here, is y equals 1/2 x minus 1/2. And just looking around the room to see if,
Sorry for the interruption, but at this time, I'd like to ask all classes to send down a student with their Shocktober collections basket and envelope to the main foyer. That's all classes to send down a student with their Shocktober collections basket and envelope to the main foyer. Also, this is just a reminder that next Thursday is the last day for Shocktober collection. That's next Thursday, so make sure to get your donations in soon, Chippewa.
Okay, pardon the interruption there. So now that we have our two equations, we need to find the coordinates of point D. That'll be the point of intersection of these two things. So I have both equations in y equals mx plus b form. Let's go over here and solve that system. So to find point D, we will solve the system that is y equals negative 2x plus 12 and y equals 1/2 x minus 1/2. I think I'm going to solve those by subtraction. So I'll just go ahead and subtract the equations. Y minus y is 0. Negative 2 minus 1/2 is negative 2.5 or negative 5 over 2x. And 12 minus negative 1/2 is plus 12.5. So that's going to be plus 25 over 2. Now, because both of these fractions are over 2, I can just go ahead and ignore the 2's. So this is going to be 0 equals negative 5x plus 25. Essentially, I just multiplied everything by 2 there. Moving the 5x to the other side by addition leaves 5x equals 25, and hence x equals 5. So I know my point of intersection of D over here has the x-coordinate of 5. Going back over here, we'll find our y-coordinate by substituting, thanks for dancing, by substituting x equals 5 in either equation. And I think it's much easier to go in this equation. So y equals negative 2x plus 12. This is going to look like y equals negative 2 times 5 plus 12, which is just going to be 2, because we have negative 10 and 12. So we know our point of intersection now. It goes to 5, 2. The last piece is I can kind of ignore everything else in the puzzle and just imagine a triangle connecting these two things. And so I'm going to use the distance formula, which is essentially the Pythagorean theorem, to find my length of my hypotenuse from E to D. So I'm going to have to erase a little bit of the board to get to there. Maybe I can squeeze it in right here. I'll just go ahead and erase this part. And I'll start with my distance formula. So my distance formula tells me the distance from E to D is given by the square root of x2 minus x1 squared plus y2 minus y1 squared. Remembering these squares just come from the fact that we're talking about the bottom, or top rather, of the Pythagorean theorem, and the left side here. So we'll substitute in our values from E and D. So I think I'll start with this point as my first point. So I'll have negative 3 and 5. So negative 3 and 5. And then that means I'll have negative 2. I forgot a negative sign there. That would have been dangerous. Negative 2 and 2. So negative 2 minus 2. Going ahead and squaring, I have negative 8 squared, which is going to be 64. And I have negative 4 squared, which is going to be 16. And so I have the square root of 80. So that is the shortest distance from point E to this particular line. Now hold on, we're not quite done yet. We can write 80 as 16 times 5. So 80 is actually 16 times 5, which means I can take the square root of 16 and bring that out. If you've done this work on your calculator and hit enter on your calculator, you probably got an answer of 4 root 5 if it can handle radicals. So this last step from here down is just the reducing of the radicals. Everything from here up, though, is exactly the work that would be expected of you on quizzes, on tests, when you're finding the closest distance from a point to a line. Don't forget to hit like, subscribe. Do join us next time when we'll be probably talking about classifying shapes on a plane. I won't make the bad Samuel L. Jackson reference on YouTube, because that would probably not let the video be posted on kids. And don't forget to check out the link in the description for the merch store. See you next time.